And now I would like to present my title, named Numerical Investigation on an Indirect Type of Natural Solar Collector for Rain. My content includes: the first one is introduction, the second one is the model for simulation, the third one is evaluation for experimental results, the final one is a conclusion. The first one, introduction. As you know, drying is the important process in the preservation of food. Pick up the moisture in wet product and keep it at a lower moisture content. However, this process we need the energy to heat air from ambient temperature to nearly 80 to 100 degrees centigrade to extract moisture from the wet product, with the advantage of having the existing high solar radiation in Vietnam. Therefore, the solar energy can be harnessed to heat the air in this process. And in this result, we designed the triangle fin solar collector of indirect type natural solar rain and investigated its thermal performance by CFD autotest. And the boundary condition in the condition is the time is 13 p.m. and we investigate it at this time through 12 months. And the face of the collector to the south, and we investigate the location in the Cần Thơ province. And this is the model for simulation. As you know, this Ryan chamber is a solar collector, and as you know, when the light, the sunlight penetrate to the glass, it you heat the collector. Therefore, the air will increase temperature, and then the hot air come the chamber and heat the food and carry and pick up the moisture of the food, and then it's stored. And in this simulation, we only simulate the solar collector from around this, and this is the figure of the collector. And you can see the thickness of the collector is 10 millimeter, and this triangle profile. And in this simulation, we use the glass wound with 50 millimeter thickness, and we use the surface glass with 5 millimeter thickness. And the total surface area contact with air is 2.8 square meter, and the triangle of solar is 30 degrees. And the inlet and outlet section has a dimension of 1000 millimeter width and 50 millimeter height, and this is a material parameter of material. And this formula for radiation is blast radiation we can obtain by this formula. Alpha is the absorption coefficient, I solar is the solar identity which absorb from outside. And in this simulation, the transmission of glass we choose 0.9, and the absorption coefficient of steel solar collection we choose 0.98. And the heat load we is expressed by Newton's law in this formula, and therefore we can choose the H, the convection coefficient, and we can choose for simulation is the 30 watt per square meter and key. and G fruit is 30 degrees is the outside temperature. As you know, we can calculate the effect of radiation heat loss from the glass by radiation by this formula, and we choose the epsilon is 0.9 to investigate the radiation heat loss from the glass surface to the surrounding temperature. And then after we adjust the condition, boundary condition and material, and we continue to create the mass calculation. The results of mass calculation is we have the total number of nodes is 45,699, and the number of elements of 160,000 and 18 elements, and you can see the shape of mass in this figure 3. And this is about the boundary of solar radiation for this simulation. In Cần Thơ province, the latitude and longitude, the position and the times we investigate is 13 p.m. and we investigate is from January to December, and the total showing time is 1,300 seconds. The gravity direction, and we evaluate the exploration results. This is the outlet temperature we want to investigate, and we have and we display on the chart. You can see that the outlet temperature is highest on the February. In the February is 88 degrees centigrade, and the lowest is in June. And as you know, because the solar density, the solar radiation is the highest in the February, therefore the outlet temperature is also highest. You can see the radiation of collection, and we can collect from the simulations. And the June, you can see that the June's solar radiation is lowest. Therefore, we can have the lowest outlet air temperature. And we investigate the solar collector temperature, and you can see the as result of the highest solar radiation. Therefore, the surface temperature of collector is also high, and the lowest will occur in the June. And you can see that the air temperature vary inside the collector, and you can see the upper of collector, the higher temperature of air we can acquire. And you can see the air which near the collector is highest because the surface of collector is high. And we can investigate the natural mass flow rate and velocity distribution. This you can see we can have the air mass flow rate. This mass flow rate have the strong correlation with solar radiation. That means with the high solar radiation we can and the high air mass flow rate we can have. And this velocity inside the air collector. And this pressure variation. As you know, when the hot air rises up, the cool air will replace, and we can see it creates the vacuum, the steady vacuum pressure inside the collector, and the pressure outside will come in. The air outlet air with the pressure atmosphere will come in. And the lowest pressure of minus 0.2 pascals, which happen in the middle of the equipment. The highest one is 0.236 pascal. And we calculate the air useful energy by using the outlet temperature, natural air mass flow rate, and the result is displayed in the figure 10. And you can see in February we can have the highest useful energy, and the lowest useful energy is occur in June. And we can predict the average convection heat transfer, and you can see because of the natural convection heat transfer strongly on the surface temperature. Conclusions: in this research, we design and investigate the indirect type natural solar collector under some conditions. The phase of south, the phase of the collector in the south, and the position in Cần Thơ province, and the time is 13 p.m. Investigate from January to December. The angle is 30 degrees, and we can acquire the outlet temperature range from 75.8 degrees centigrade to 88.46 Celsius degrees. And we can obtain the natural air flow rate from 10.34 grams per second to the 11.94 grams per second. Therefore, it's eligible for agricultural rain. In general, all parameters have a strong relation with the solar radiation. The higher solar radiation intensity, the higher outlet temperature, mass flow rate, useful energy we will have. And thank you for listening.